All right, so let's talk about the instructions first. It says that it wants you to write the ratio of x to y. Now remember, we could write that as a fraction, but another way to do it is this, right? And so this is what it says. Hint, in exercises 37 to 45, collect x terms on one side and y terms on the other, and then factor. So we'll kind of see what happens. Okay, and they also give us this one example, so that's what I'm going to follow when I'm doing this one. So if I get the x's and y's already on one side, right, it looks to me like what they want us to do is get the x and the y over each other. So if I were trying to do that, here's what I would do. I want to get the y underneath the x so that it kind of looks like this, because if you look at the sample problem they give you, they have x over y equal something over something. They're basically having you rewrite this as a proportion, aren't they? So what I want to do is I want to get the y underneath the x. So here's the x. If I want to get the y underneath it, couldn't I divide out the y by both sides? That'd be one way to kind of start working that direction. So that would leave me kx over y is 2. Okay, so that's just kind of just following the solution example for the sample here. Now they really want this x over y by itself, but it's got a k multiplied by it. How can I get rid of the k?
Multiply by k?
Well, if I multiply by k, that's going to give me k squared and 2k. It's actually going to create more k's, right? So, but this is multiplied by k. The opposite of multiplying would be divide it. So that's what we want to do. We want to divide both sides by k, because then the k's are going to cancel out, right? So I got x over y is equal to 2 over k, and that's what they're wanting. They either want it, I mean, you could write it like that, 2 over k, or you could even put it 2 to k. You know, I'm not sure what they're doing in the answer key, but I'm going to guess that they're going to write it as this. Did you look and see already, or? Let me just say this with the video on. It's like you're solving for x divided by y. So you already got the x on top. So the idea is let me move the y over there since the x is already on top like I want to get it. And so you're just basically you're moving stuff around by doing the opposite thing. You're used to solving for one variable or, something like that. This is kind of weird because they just want you to move this y underneath the x and then move everything else to the other side. So it's kind of a weird thing. You done 33 already?
Yeah.
Is that what you did, or?
What I was having trouble on was,
Okay, so let me turn that on. Let's look at 37. Okay, 37 looks really wicked. 4 times x plus y. I didn't even realize I assigned this far down. I thought I stopped at 35, did I? I'm going to look at it just in case you're curious. Okay, so they want me to get x over y. Now I'm looking at this going, ooh, this scared me a little bit. One thing I would do here, one thing you could try is if they want to get x over y and solve for that, it's like if I move the stuff around like I did in problem 35 and I divided both sides maybe by x minus y, it's not really getting me anywhere, is it?
I tried distributing and then working.
That's what I think I would do. So those didn't look good. So let's try that, because I think that's probably, but I don't know. When I look at stuff like this always scares me a little bit. 4x plus 4, oh yeah, that's exactly what you want to do. And then over here you've got 8x minus 8y. I actually already did distribute here. I just wrote it down. It's like I just did it so automatically that I didn't, it should have been written like this, and then I should write 8x minus 8y. So what I want to do is get the x's on top and the y's on bottom. Let's kind of combine some like terms at first. For instance, I see that I got the y's over here, and I know I kind of want them all together because that's the problem with what we tried to do up here is they weren't all together. So let me do this. Let me move this 8y over here. Okay, so you'd have 4x plus 12y is equal now to 8x, right? But the x's aren't together, are they? But couldn't I move these x's over to be with those x's? So I could subtract 4x. It's working out better than I thought it was going to. So now I have 12y equal 4x. And if you're listening at home, I know this one wasn't assigned, but it's kind of a good challenge problem here. All right, so I'm going to get a new slide going. Is 4x. Now I can do the same thing on this one that we did on 35. I can say I want to get the x's on top and the y's on bottom. I want to make it look like x over y equals something over something, okay? So, okay, if I want the x's on top, they're on top over here on the right-hand side. So let me leave my x's there. Let me divide. I want a y on the bottom. I'm trying to make what I have here look like this, okay? So let me get a y on the bottom. That would cancel those out. And I'd be left with 12 equal 4x over y. And now I've got the x over y part. The only thing is I've got a little bit extra. I've got that 4 there. I've got 4 times all of that x over y that I'm trying to get by itself. What would be the opposite of multiplying x over y by 4? Dividing by 4. Okay, so let's divide both sides by 4. And I would get 12 divided by 4 is 3. That would cancel out and be 1. And I would have my x over y here. Now, they're really wanting you to express it as a kind of as a proportion if you think about it. So probably what you should do is put 3 over 1. They may just say it's 3, but I'm betting they're going to write 3 over 1.
3 colon 1.
So they're doing this 3 colon 1 is another way of writing that same thing. So this is the x, the ratio of the x to the y. They're saying that if I want to know, like, we use this in geometry and similar triangles. If I want to know, like, the ratio of x to y, it's going to be 3 to 1. For instance, I may have a triangle, for instance, that's got a side of 1, and then maybe the other one is 3 times bigger or something. That's how we'll end up using this stuff in geometry, though it usually doesn't look this complicated. It's usually a lot easier to explain than this type problem.